Good evening, everyone, and greetings from JIO Institute. I warmly welcome you to another interesting session. And today's session is Meet the Experts of the Artificial Intelligence and Data Sciences. Let me start by introducing you all to Dr. Salish Kumar, who is the program mentor of the AIDS, which is the Artificial Intelligence Data Sciences program here at JIO Institute. He is also the Chief Data Scientist of the Center of Excellence in AI and ML at Reliance JIO. Next up is Dr. Vishnu Prasad Nagadevra. He is the former professor and dean at IIM Bengaluru. Next is Dr. Dwarikanath Mahapatra. He is a senior research assistant at the Incubation Institute of Artificial Intelligence at UAE. And lastly is Mrs. Shreya Agarwal, who is the director of data sciences at Fractal AI. So we'll have Dr. Salish Kumar take over first, and then we'll go one by one.
So good evening, everyone. We started JIO Institute. It's now a one-year-old program, and the first batch is graduating. And the conception of the program was that we have a lot of requirement for AI and data science, and the field is evolving very quickly. And the skill set that we need in the next 20 years is very different than the skill sets we need in the last 20 years for AI data science, right? Thanks to all the progress that has happened. The fundamentals remain the same, but the skill set, the tools, the concepts, the way we learn, and all that is going to continue to evolve as these programs will evolve, right? So, we have put together a very robust curriculum in terms of both, covering the foundations and the first principles learning of AI, intuitive learning of AI and data science, then theoretical learning of AI and data science, and then a lot of hands-on learning and application-based learning. So we are trying to create a program which kind of prepares the full stack data scientist, if you will, who understands, the mathematical foundations as well as how to implement and deploy models at the industry scale, right? So the whole spectrum of theoretical to practical. The program is taught by world-class faculty, and some of them are here. Today, you will interact with them. These faculties have both a mix of industrial and academic experience and a lot of research experience. They have written books, and they are on a lot of research programs, and they've taught for many, many years. So they're all very, very, proficient in the fields that they're teaching. And so the kind of faculty that we have, the kind of curriculum we have put together, and the kind of facilities that we have. In addition to all this, we have also added what we call AI for X series, which basically talks about how AI is applied to different fields in different verticals. And the idea is that, we can know the tools, but if we don't know how to apply them to different verticals, it doesn't, connect. So this series is by industry experts who talk about how AI is applied to different fields. So we get a sense of how to formulate AI algorithms and ideas into what we call, industry scale AI architectures and processes and platforms, right? So that is kind of the way the program is. We see a lot of requirement from many, many industries today who are very data rich, but want to become AI first companies. The format of how to do it is still evolving, but there's a very clear idea of what are the skill sets needed and how do we transform an organization into an AI first organization, right? And that's the journey that all countries, all organizations, governments are taking. And this is a very rich program considering the past 20 years of AI and the next 20 years of AI, how we have kind of designed the program to give a very holistic, outcome for our students. Our students can graduate as researchers who want to do further research in this area to advance the state of the art. They can also graduate as, hardcore data scientists, which can work in industries and build great models and all of that. And they can also graduate as entrepreneurs who can actually create AI first companies, AI first platforms. And we want to support all kinds of outcomes through this program. So it's not a one size fits all program. Depending on whether you come from a lot of domain knowledge and less of math, or if you come from a lot of mathematical thinking and less of domain knowledge, or if you are just an entrepreneur and you want to solve some great problems for the world, it doesn't matter what kind of a person you are. We have bits and pieces for all of you to help, sort of move the country forward and move the world forward with this amazing field. Yeah. So with that, I'll stop. I'll take questions later. Let me pass on to Professor Nagdev Rai and
We'll
Sir
have Professor Shreya Garwal next.
Shreya Gaurav. Okay. Yeah, Shreya, go ahead.
No worries. Thank you so much, Dr. Salish. It's always nice to hear from you the vision of what we want to do. Hi guys, I'm Shreya Agarwal. I have been faculty at JIO Institute for the last batch, where I taught a very interesting subject called Responsible and Ethical AI. I'm based out of London, work for a consulting firm, also part of United Nations, and has been um, you know, uh, awarded Microsoft Most Valuable Professional for 3 years. I have also written a book, probably I may not be, I may be wrong, but probably one of its kind book in the world on responsible AI, um, which which talks about the fundamentals of when you do AI, why you need to be ethical and responsible. I will not talk about what we will teach, but I'll talk about why it is important, given the fact that there has been that AI touches every aspect of your life. So it is very, very important for us to ensure that we are ethical and responsible when we use AI. And you have seen all this noise going around when it comes to generative AI and things like that. Last batch, we did amazing 15 hours of session, did around 15 real life project, almost real life project, and it was phenomenal. So what is the best thing at Geo when I teach this kind of paper, um, is how students are able to amalgate multiple things. So be it their statistical knowledge, data visualization knowledge, machine learning knowledge, everything, and then come out with a project. So for me, if I have to summarize, every project at Geo Institute which are done by student is itself a mini capstone project. So you would be doing a major capstone project. Every project is a capstone project, and every time you learn so much, and the way you can amalgate. And as Dr. Salish told about, you can become an entrepreneur, start a startup, become an employee. But the most interesting thing is, if you enter Geo with a vision that I'll become an employee, you may come out as a founder. If you enter as a founder, you can go and say, "Oh, I want to do PhD." So the environment is so very experimentative that a lot of time the aim with which you come in is not the output which you go out. It's more like a machine learning, input process and output. The output may be really, really different with a lot of noise into it. So looking forward, and I'm very, very sure the kind of sessions, and the best thing is it's a residential program. And when I was there for the last batch, I thought, oh, we'll have 15-hour session, maybe 15-hour more of office hours. And miss, everybody is aware that how students were in my room talking to me at 3 a.m. in the night. So if I've taken 15 hours of classroom session, they have learned 10,000 times more by hundreds of more hour outside classroom session. And that's the most interesting thing. And responsible AI as a paper is one of the most demanded um, job or skill set right now in the world, and it's very, very experimentative, very new, very it's evolving, so you'll enjoy. And the libraries you have, the kind of faculties you have, the way you interact with the students is very, very, very interesting. And I guess every day at Geo would be equal to 10 hours of learning. So every 1 hour of learning at Geo is equal to 10 hours of learning everywhere else. And I can vouch for it, not only for students, but also for faculty. Means I have learned so much from my students. And the mix of students you'll have, there are people who are amazing programmers, statistician, engineers, people coming from business domain. So if you interact with them, so you'll be actually doing 4 or 5 courses inside a classroom because you'll be learning so much from your friends and colleagues. I guess I've talked a lot. I'll pass it on to the host. Thank you.
Thank you.
We can now pass on to Professor Nagadevra.
Thank you, Christian. I'm very happy to be here and share my experiences of teaching from last year. I did 2 modules last year. One is on optimization. The other is on forecasting. Even though we call it optimization, it is actually mathematical modeling. Many times the minute I utter these words mathematical modeling, some students tend to switch off. But what's interesting about JIO is the way we handle these programs or these courses is purely on the practical application. The way we do it is every day, it's a new case. The case drawn from a real life situation. So you're actually put into a situation where you have to take decisions and see what are the implications of your decisions. So it's a completely practice oriented. Does not mean that you don't get theory. But the way I structure the course is you look at the case and the theory that you require to get the solution or to facilitate decision making evolves from that practical scenario. I'm not going to go into what are the different topics that we deal with in the course, but this is one particular course where just by applying many of these techniques, the bottom line can be increased multiple times without any additional cost. It's actually clear-cut application where you apply your brain power to increase your profits. That's about the math optimization course. The minute I say mathematical modeling, remember there is a term called mathematical there, but there is not high funda mathematics. We actually try to make it easy. Whatever little mathematical background you require, assuming that you are not from the mathematical background, we'll give it to you in a small, shorter module where we talk about what are the different aspects of, let's say, algebra or linear algebra that you require to get through this particular course. But whatever mathematics are involved, we'll actually let the computer software take care of that. So you concentrate on, number one, model building in a practical scenario. Let the software take care of the solution process, get the solution. But once you get the solution, the emphasis again is on interpretation of the solution. And most important, strategization based on the solution that you got. It's not that the solution that you get is hard-coded. As a manager, you look at what is feasible out of the solution. And if you don't like some part of that solution, what else can we do? So as a matter of fact, you are put into a CEO kind of a scenario where you have to take the decision, but the decision is supported by a mathematical model. I'll just say a couple of sentences about the other course, forecasting. Believe it or not, every one of us is a forecaster first, then anything else. We do forecast in our personal life. We do forecasting in professional life. If you're an entrepreneur, you know what you need to do? You need to forecast what the customers demand or what the customer is likely to ask for 3 months into the future. Because you need 3 months to figure out what the customer would want 3 months from now. Create your manufacturing facilities for that. Get the resources, go through the production process, use supply chain to take your product to each and every street corner. Make sure that when the customer walks in, asks for a particular product, it's available immediately. So as I said, every one of us is a forecaster, whether you are in HR, artificial intelligence, service, production, finance. The very first thing you need to do is forecast into the future. So we'll again talk about different methods of forecasting. Actually, the model, the course is called not forecasting, but time series analysis, but basically deals with forecasting. Again, it's completely practice oriented. Every class will talk about forecasting in a different industry, different technique, different data sets. So by the time you get through the entire course, you would have been exposed to different industries, different techniques, different data sets, different problems, issues involved in forecasting. This is where I think I should pass on to the next. I talked too long. So here is the next speaker. Let me pass it on.
Thank you so much, sir. We have next up is Dr. Mahapatra. He will now address you.
Hello, everyone, and hello, Professor Salish and all my co-panelists. So my name is Dwarikanath Mahapatra, and I am a senior research scientist at the Incubation Institute of Artificial Intelligence in Abu Dhabi in the UAE. So my research expertise is in the field of computer vision, medical image analysis, and obviously applying AI, deep learning techniques. So some of the things that I work on are basically transcend the boundaries of computer vision, medical imaging, and learning in low data scenarios, learning explainable AI. So in the at JIO Institute, I have taught the foundations of computer vision course, and also the be teaching the deep learning for computer vision course. And my my experience at when in my first class at JIO Institute, I had a very interesting experience. Lots of them related. So when I started the course in my introductory slide, so I wanted to get to know the class a bit more, what is the background of the students and all. So out of almost like 58, 60 students, a few of them had background in computer vision, and but many of them, I think almost 50% had a background in other areas, starting from pharma, as someone had background in mechanical engineering and all this. So when I started interacting with them, and the first questions they asked me in different ways is, what is the need of this course, Foundations of Computer Vision? Because apparently in the earlier quarter, they had already learned a bit about deep learning, and there they had this idea of how convolutional neural networks work, how it's applied to images and all. So my first task, in a way, was to convince them that Foundations of Computer Vision has a place. It's important to know. So, so the point I'm trying to what I tried to learn is that students they see it's a fact that the whole explosion of AI and the whole growth of AI or hype around AI is being driven primarily by maybe 2 or 3 fields. One is, of course, natural language processing with the recent ChatGPT, then with computer vision, and of course, new current recent fields of AI like responsible AI, ethical AI, and all that. So, so it was kind of, I felt that students, they really wanted to, they didn't want to have a black box approach to understanding AI. It's not like, okay, we take an image, we take a network, or we take a pre-trained network, put the commands in, like design a network, train it, and that's it. It spits out some number. So, so I believe some students had this approach that we already have all these networks. We just plug it in take the input, plug the network, get the output. But what I feel is that when you are working on a field, it's very important to understand how this field evolved. And as a matter of fact, all the stuff that the neural networks do, especially in the field of computer vision, is actually based on the research work that has been built up over the last 40 years, 30 years, starting from 1960s up to now 50, almost 60 years. So even though what I would like to advise is that when you do get started in AI, try to understand how it works, how the things work. I mean, if you are learning about random forest or object detection, you should get an idea of how it works. I think that also helps you to learn, that improves your motivation to learn. And also, as I taught students at JIO Institute, I found the experience was also very enriching. Students had very capable students. There were very capable students, lots of ideas, and spanning across diverse fields. And in fact, we had one entire session of almost 1.5 hours discussing about different potential applications of computer vision. And students started suggesting applications based on their background. And even then, they were not sure that, and to them also, it was a revelation that, yes, they didn't know that we could use computer vision in their field. So I think, so as we understand more about the foundations of certain fields, we can relate that much easier to our own field of learning. So yes, so that's all I would like to say at this stage. Thank you.
Thank you so much, sir. Would any of the faculty like to add any more thoughts? Salish sir or Professor Nagdev, or can we move on to the Q&A?
But as I said earlier, what's special about the JIO Institute is its practical approach to the program. Everything that we talk about is how do we apply this in a real life situation. I think that's what stands us apart from other such programs, whether it is my course like mathematical modeling or application of artificial intelligence, or as Professor Mahapatra said, machine learning. Everything is practice oriented, real life scenarios.
Great, thank you. Salish, would you like to add something?
Sorry, I missed the question. What was the question?
No, just any other thoughts that you would like to add in here.
Yeah, so like sir said, I think, there are many programs out there that try to cover AI data science in their own way. And what we've done is we have tried to take a very tactical and strategic view on how do we do it. Some of the skill sets that we have added are sort of design thinking skill sets, right? Or what we call formulation thinking skill sets, or system thinking skill set, or solution thinking. So while we can know all the tools and algorithms on one side, if we don't know how to create an AI strategy for a company, how to create an AI architecture for a company, right? So how do you think about AI both at a box level, at an algorithm level, and also at a system level, right? How does it integrate with the running workflows of a company, right? Of a business. So this practical approach to saying, I know how to build and deploy models. I also know which models to build. I also know that for a business problem, how to create an AI architecture for that business, right? Like, for example, you don't just build one model and say, I'm done. You need to build multiple models to finish a workflow, right? So if you want to build supply chain for retail, you don't just build one model, right? And like Professor Vishnu said, right, you have to do demand forecasting. The output of that goes into another model, which will do, inventory optimization or pricing optimization or supply optimization, right? So the idea that, like a human body is a mix of many, many components working together as a single whole, it's a system. And that is the approach that we want us to learn, that, we are building a system of intelligence which contains many, many components. Some of them are pure IT components, some are AI components, some are very advanced AI components. How do they work together as a single whole is one of the, end results of this program. So you know how each part works and you know how the whole works. And that skill set is what I see missing. So I've taught for the last 20 years. I'm sure many people have taught for many, many years. But the skill set today that is missing is that if people are given a business problem, they are not sure which technique to apply, how to convert that into 5 models working together. That skill set is very important. So we work in, at all levels, right? The other way the program is very unique is we are very solution centric in our thought process, right? We don't start with a data set and say, hey, let's do something with it. We want to work backwards from a business problem or a societal problem, right? So if you want to transform healthcare in a country, how do you think backwards from the problem statement, right? If you want to solve agriculture, education, climate change, many, many problems that society is facing today, most data scientists who come from the Kaggle route, they say, show me where the data is, I will do something with it. That's the wrong approach. We data science does not start with data. It really starts with the problem statement, right? So, or the solution you want to build. So the idea is, how do you think backward from the solution, not forward from the data? This is the mindset shift that we want to bring about, right? And there could be many, many data sources to solve a single problem. How do you think about all of that? How do you think about data as a resource, which can be, used to create a lot of value, and algorithms as a resource? But really, the overall skill set is to formulate the business problem as an AI architecture. So in my mind, the role of a data scientist is evolving to become the role of an AI architect. And that's what we want to train, because hands-on data science modeling has already been taken over, right? If you look at tools like H2O and all, now the building of models, deploying of models, monitoring of models is mostly automated. We still have to know the fundamentals, but we don't have to do it manually, right? It has been automated. So what is the new skill set of an AI expert in the next 5 to 10 years is not to write a code to build a new algorithm, to write, to create a new algorithm, code up an algorithm, but really to apply that to different, business problems correctly, right? As an architecture. So I think the higher order skill set thinking is what we are trying to develop, while also giving you a beautiful intuitive understanding. In my class, at least, we derive all the math, not that I derive the math, but students derive the math. And the reason we do that is to feel the joy of how beautiful these algorithms are when they were invented. And when you invent your own algorithm yourself in a class, you will never forget it, right? So we do invention at that level, right? The invention that have been done in the past, we reinvent those algorithms in class, and we solve business problems. So we are inventing at both levels, algorithmic invention and business and application invention. And that is what makes this course a lot more joy than, just a very academic, get some grades kind of a course. Yeah. And if you look at the list of capstone projects that our students are doing, it's amazing. We are solving climate change problems, agriculture problems, education, personalization problems, including stock market problems, all kinds of problems. The diversity, in the retail world, we are solving some problems. So the diversity of problems people are solving is amazing. One team is solving a problem of AI to legal domain, right? How do you predict whether a case will be won or lost given the input, right? So there are some crazy problems people are solving. not your run-of-the-mill, download a data set, build a model, right? They are really solving an interesting problem, which requires them to know multiple ideas from multiple courses. So they're combining all of them together, like Shrey was saying earlier, right? And that's how we get that kind of a broad perspective on AI. Thank you.
Yeah. Thank you, sir. I think now we can move on to the Q&A, and any faculty could feel free to answer this. Benson Kahura from Kenya wants to know how data science and artificial intelligence can be applied in financial field like portfolio fund management and bot trading.
Yeah, so I think Shrey has worked in the financial domain. You want to take that? All right.
I think Shreya had to exit, sir.
Oh, okay, okay.
So,
No problem. So basically, if you look at the financial sector, there's a whole bunch of areas. If I look at banking, for example, before I go to financial, so banking sector, we need a lot of AI data science in credit modeling, in fraud modeling, and in investment banking, right? So all these areas are using a lot of AI to optimize that one little thing, right? Should I buy or sell now or later? How much should I do it, right? Portfolio optimization. How do I mix my portfolio to, get the maximum return on investment, right? And today, credit modeling has become a completely very difficult topic, because we are not just doing individuals credit modeling, we are also doing businesses credit modeling. So the SME modeling, how do you build a credit model for a barber business versus a farmer versus a taxi driver, for example, right? Or a dosa shop, for example. So building credit models for different verticals, different sizes of businesses is a very complex problem. Building credit models for individuals across the spectrum of income is very complex problem. Fraud, if you look at UPI and online transactions, there's a lot of fraud that is happening. How do you prevent fraud? Because a lot of people are losing money on fraud, right? You hear stories, there are Netflix series on how fraudsters are taking away money, right? So how do you catch that in different levels? So fraud is one area, credit is one area, and this portfolio optimization is a big area, and many such areas are coming up in fintech world that need a lot of help. Economic modeling, for example, right? Is this policy decision going to benefit or not? What would be the GDP forecast of a country if I increase the price of this or decrease the interest rate on that? So these decisions, the policy decisions, the import-export decisions, can be now driven by AI simulators. Yeah. So, it is applied in many ways in the entire sector. Yeah. Banking, finance, economics, all these areas.
thank you, sir. Dr. Mahapatra, Dr. Navira, would you like to add to this?
I would just add 1-2 sentences to what Salish said. In any portfolio management, what's ultimately required is you want to maximize your return and minimize the risk at the same time. So basically, we do that kind of a trade-off, or the balancing of return versus risk in the mathematical modeling course. So that mathematical model will help you to figure out the kind of stocks that you want to put in your portfolio. Not just the stocks, it can be any kind of financial instrument. And more important, you may even want to do some kind of a simulation of the market. What would happen to your portfolio under different situations? We cover those, and then these can be automated applying artificial intelligence. So, but please remember, the rules that the AI needs to follow come out of your model and the kind of trade-off you are ready to do. For example, at my age, return is more important to me, and I want to absolutely minimize the risk. I'm not in a position to take up any risk. But a young professional will be willing to take a higher risk and at the same time increase the returns. So again, what is your risk bearing capability? And your returns depend on that. And how do I design a portfolio based on the risk appetite of the customers? That's how you can apply this knowledge to portfolio management.
Thank you, sir. Let's move on to the next question. I have gone through the courses listed on the website and they cover extensive list of topics. How are the courses arranged and what are the class structure like, and how many hours are the classes of the course per day?
So basically we have divided the whole course into 4 quarters, right? The first quarter is what we call the foundation quarter, where we talk about, the basic courses that are a must to understand the rest of the courses, right? So fundamentals of probability and statistics, basic statistics, and then later on advanced statistics, a little bit of calculus, optimization, little bit of linear algebra and all of that. So that is one set of courses. The whole mathematical foundation for AI and data science is the new course we are introducing this quarter. We learned that because that course was not there, some of the students who did not have a strong mathematical background were struggling. So we introduced that course. Then, some people did not come with a very strong programming background. So we introduced in this next year, we are going to introduce a very strong coding Python program, which will be fundamentals of coding all the way to Python for machine learning and data science. So the coding skill set and the mathematical skill set will become very strong at par, right, with each other, right? Those two. And then apart from that, many other basic courses like databases and data warehouses, data visualization and all of that. So you're comfortable with data, comfortable with code, comfortable with mathematics, right? So that's kind of the foundation courses. And then we start with the horizontal. We look at 2 quarters of core courses, all the way from machine learning, deep learning, statistics, and NLP, speech and vision. So you get a broad perspective on data science, right? Because we don't know what you are going to do, which field you are going to pick later, what will, excite you. So we've said, let's make sure that we all understand all the different varieties of topics that form a complete foundation of the data science field. And also for the other reason, because if you want to go to a complex organization, you want to know that there are different areas of machine learning data science that are needed to put together a solution, right? And then in the last quarter, we focus on, capstone project and what we call electives, advanced electives, where you have a chance to take advanced topics in statistics, advanced topics in machine learning, deep learning, vision, speech, and all that. So there you can pick 1 or 2 areas that you want to really focus on. And because that is what was interesting to you in the second and third quarter. Apart from this, we also have what we call a international module where our students go to an international university. So we have tie-up with multiple universities. Our first batch went to the Singapore University, NTU, and they are learning some courses there. They're absorbing the culture, the learning culture. They're interacting with their faculty and all that. So they're getting a lot of good international exposure while they spend 2-3 weeks there, right? So that is a very important part of the overall module. So you'll get an international exposure to a very world-class university out there. And the way the class looks like, so we have 4 hours of teaching in the morning and then 4 hours of lab. So this is the typical day looks like, right? Which will engage you. 4 hours of learning in the morning, 4 hours of lab. And one of the days in the week, maybe Wednesday or Saturday, is free for industry lectures, doing your own homework, assignments, hackathons, whatever you want to do. And obviously the weekend is available. So it's a combination of light and lot of intensity and light combination. So, and like Shrey said earlier, right, 1 hour of classroom is like a lot of work for you as a student, going back and doing the homework. So while it looks very intense, it is also very light. There's enough space to catch up, talk to people, collaborate, do projects, and homeworks together. So a lot of that is also available. And yeah, so it's a very thorough course, both on a daily basis and quarterly basis and yearly basis. Yeah.
Thank you, sir. Moving on to the next question, is the AI and DS course better than a 2-year master's course?
Yeah, I can take that if anybody. Yeah. So see the, this is a full-time course, right? And a very intense full-time course. And what we are doing is we are experimenting with this idea that the right skill sets taught in the right order, compressed in 1 year, will make it beneficial both for the student, because you don't want to spend 2 years learning something and then going into the market, right? So 1 year, we have experimented with it in the first year, and I think we've learned a lot, but we still are very confident that 1 year is a sufficient time to capture all aspects of data science if it's a full-time course, the way we are teaching, right? We are also assuming that since you're coming with 18 months, at least 18 months to 2 years of work experience, you already bring some level of maturity and discipline that you can handle the kind of intensity that a 1 year program brings in. Now, if you look at the ISP program, right? ISP is one of the top 6, business schools in the world now. And they have really mastered the 1 year program, right? ISP program is a 1 year PGP program, not a 2 year MBA program like other IIMs. And there, the quality of education, the quality of jobs that they get is amazing, right? It's one of the top 6 business schools in the world. So I think intensity for 1 year really seems like a sufficient thing. And later we may play with more time, maybe another 6 months for finishing a master's thesis or something else if needed. But for now, it's a 1 year intensive program. Yeah? And like Shrey said, kids learn 24 hours. It's not just, during classrooms and all, right? You can barge into a faculty place late night and have a conversation. So dinner conversation, lunch conversation. So it's a continuous learning program. And therefore, I think 1 year seems like a good idea.
Thank you, sir. Anyone else like to chip in, or can I move into the next question? Okay. So, similar question. What are the placement opportunities that 1 year graduate would get over a 2 years master's graduate?
Yeah, anybody? So I can talk about it. We just closed our first round of interviews, and we were amazed that within on the first day of interview, we had invited some I don't know 20 companies. They spanned from consulting companies to services companies to product companies to large businesses like within the Reliance ecosystem and outside. Out of a batch of 60, almost more than 55-60% got placed in the first day itself, and the salaries were pretty good. And I think the quality of education that we are giving is quite matching the quality of education of a 2 year program. So I don't think that a 1 year versus 2 year is a big difference, because today the amount of learning that the students have to do is smarter learning, not high volume learning, because data science is not something you learn first and then apply. It's a continuous learning, right? You learn something in 1 year program, then when you go to industry, you continue to learn. After 20 years, I am also still learning, because the field is evolving, right? And so I think in terms of 1 year versus 2 year, I don't think we should worry about. We are saving you 2 years, 1 year, because it's a 1 year program, and you will get a head start from others. But the quality of jobs that you are getting based on our experience is still the same as you would have gotten, or better than what you've gotten in the 2 year program. So I won't worry about that.
And if I may add, sorry,
Yes,
Professor
yeah,
Shailesh,
yeah.
so I think the 1 year program also has the advantage that you are learning things very up to date. For example, when you learn the basics of data science or machine learning, and then you start working in an actual real world setting, you get to know the different nuances of real world problems. 2 year courses, of course, they have their own place. They also are good, but what Professor Salish said earlier, that focused learning, compressed focused learning, that when you focus on a specific topic or a module for a few weeks, and then you learn it better than trying to learn multiple things at the same time and trying to do multiple projects. So I guess I definitely believe that this focused learning would be very much productive, and students get to know the latest skill sets. They get to also the capstone projects which they're probably working on virtually throughout the year, and that kind of helps you to apply what you learn in the courses throughout the year on a much bigger scale. So yes, the learning is always ongoing, and in a way these courses provide you the different ingredients to help you go and do your bigger capstone project much better.
Thank you, sir. The next question is there an incubation center to support startups?
Yes, so there is a Reliance Incubation Center, right? We call it the JIO Gen Next, which has been running for the last almost a decade now. And we support a lot of startups there who apply. They have their own application process. So that is available for anybody who has a viable startup idea and who has done a capstone project which has reached a stage which is worthy of a VC funding level 1, right? Like Series A funding. So if you have shown or proven the value of your idea up to that level, then we have a GeoGenNest program that can support you and guide you further. We also are going to start a incubation center of JIO Institute also later in the future, but we do have a lot of support for incubation. We have a lot of talks coming, we invite a lot of entrepreneurs, leadership coaches to help our students who want to get into that line to kind of get exposed to this idea of what all other skill sets I need apart from being technically solid. What are the business skills, the finance skills that we need to run a successful startup, right? And I think there's a lot of environment for fostering innovation and entrepreneurship. That's what the foundation of Reliance Industry is. And we support a lot of such thought processes. And there's a lot of scope for, if you prove your idea to be worthy of a VC funding. So just imagine a capstone project which is oriented towards a startup. Its outcome is a pitch to a VC for a Series A funding. That is the outcome we are looking at, which is, and if it gets funded, then we will help within the Reliance ecosystem through JioGen Next or outside, and we have a lot of connection in the various ecosystems out there. And at some point, we will also have our own incubation center.
Yep, thank you, sir. We'll take one last question. So how effective is a PGP in data science and artificial intelligence in terms of knowledge coverage and industry exposure to the students, so they have real world exposure? Additionally, how is all this possible or achievable in just 1 year?
Yeah, go ahead, anyone? Okay.
Yeah, maybe I can just
go ahead,
start out with what we worked on computer vision. So if you look at computer vision, it is present in all aspects of your life. As everyone has a smartphone. Every smartphone has a camera, and you are able to do so many things. When you get to understand how this technology of detecting a smile, detecting emotions, how do you get these different kinds of avatars, and the different kinds of pre-processing, post-processing, that things happen. So you see, this is So this is one aspect of, this is to help you connect with what you're learning to what you're actually using in life. So we don't really think of how does when you point your phone at a group photo, why does it show green rectangles on the faces? So how does this face detection work? And before the advent of deep learning or AI, when it took off, how were these algorithms implemented? They were implemented much before the AI revolution. So I think this is one aspect. And then real world applications, like it's not just, if you look at, agriculture. So ag-tech or agri-tech, predicting where there is pest from satellite images, or from monitoring livestock from thermal images, or monitoring pest food quality from camera images, healthcare, like health. How do you, looking at an MRI or an X-ray, how do doctors make decisions? How can we automate all that? So all these things definitely have a place, applications have a place in our society. And considering the fact that we, in my class, I definitely we look a lot at the real world problems, not just the theory, but how it is done in an industrial setting. What are and it's not just about the core competency of computer vision or NLP or whatever, but also how you put everything into a system. So it's all when you graduate, you would know how, if you are given a real world problem as a data scientist, you would know exactly how to start out with the data, how you do the data cleaning, how you start thinking in a high level perspective, then going on to the details. Like Professor Salish said earlier, it's not just about give me the data, I will do whatever I want to do, but you think about the problem, you break it down to different subcomponents, and you understand what are the skills required for these components, whether what skills you have, what are your strengths, what are your colleagues' strengths, how you can leverage. So it gives a very broad idea, as well as a fairly good idea in depth about how about the different aspects of AI, different application areas.
So just to add to that, see, the field of AI is now very, very broad, right? I think many people have contributed to the field, all the way from mathematicians, statisticians, computer scientists, psychologists, many people, neuroscientists, many people have contributed to this field. It is very diverse, like mathematics, like physics, like chemistry. AI is also becoming, it's very early in terms of the, how mature those fields are. AI is getting there very, very quickly, because, the number of people who are working in this field is grown exponentially in the last decade. So the kind of ideas that are happening, the number of conferences that are getting, papers are getting published, the pace at which it is evolving is just mind-boggling, right? So obviously, with such a large field which is continuously evolving, it's not easy to finish everything, right? Even if we spend 4 years, we'll not be able to finish everything, because by the time 4 years are over, another 20 years of work has been created, right? So what we've done is we have given a T-shaped learning module, right? So the T-shape is you learn everything at a right level of abstraction. So you know what are the possible tools that are available, how to use them, what are the different ideas that have contributed to the field of AI's development. You learn to invent and you learn to apply. You learn both. You learn in both ways, all those ideas intuitively. So you get a sense of what are the possibilities. See, one of the problems I see is there are business thinkers and product thinkers who don't know about the possibility of the tools. So they don't know that facial recognition can be used to do attendance in their factories, and they're still doing factory attendance in the old way, right? They don't know the possibilities. Now, when you put a data scientist who is very broad in his thought process, who understands all the components that are available, right? What can you do with speech, language, vision, machine learning, deep learning, knowledge graph? When somebody with a very broad set of ideas talks to a senior business leader, they can really put together the broader architecture, right? I can apply NLP here, I can apply optimization there, and this is how the whole thing will look like. So we need a breadth thinking, and we also need depth thinking, because we want to be able to do something very special in a particular area which is closer to the state of the art. How is the generative AI working now? I cannot wait for a textbook to emerge. I want to be able to teach that right away with the great faculties that we have, right? So how do you keep the depth and the breadth balance was one of our challenges. And we said, look, I think if we cover these in the breadth and give students the choice in the depth, what they want to pursue, then it'll be a nice mix of what is compulsory, what is elective, and it'll give them all those areas, right? And I don't know if I covered all aspects of the question. Let me just see what the question was again. Was the sorry, I missed the future of PhD. Package information is already published on the website. I think our average package, you can look up the website. They have updated the numbers. But let me see, did I answer that question?
Pretty much you did, so.
Sorry?
Yeah, it's pretty much answered, I suppose.
Yeah, okay.
So anyways, yeah. Now I think we can bring today's session to an end. And before we sign off, I would like to thank Dr. Salish Kumar for coming in, Dr. Dwarikanath Mahapatra for coming in today, and again, Dr. Vishnu Nagadeva. It was a pleasure listening to you, and I'm sure there's a lot that we've taken back from the course. And as for the participants, the admissions are open. You can always call us or visit our website. Come and visit the campus. We are open. You can come and visit us from 11 to 8 in the evening. And we'll see you here, and we'll see you in the program. Thank you. Good night, everyone.
Thank you.
Thank you. Thank you.
Good night, everyone. All the best to you guys, all the participants.
Thank you. All the best.
Thank you. Nice meeting you, Salish, again.
Yeah,
Dwarikanath.
nice meeting you, sir. Thank you. Yeah.
Same here, Professor Vishnu.
Good night.
Thank you.
Right,
Bye.
yeah.